Okay, so we'll start. It's 4 p.m. And once again, thank you all for attending this webinar. And we know that data science is the buzzword right now, and everybody wants to get into that. The particular problem here is when you want to transition from a non-IT field into data science. That's a sort of a lengthy bridge to cross over. Okay, so here's what I got for you in the beginning. In the beginning, we would want to transition from our previous academic disposition into data science. But this is not just a decision or some disciplined academic conformism. You just don't take a course and then do all the basic requisites over there and just finish it off. It's not going to work like that. Okay. So what we have here is we have to understand in the beginning that their training needs to come from within. We have to appreciate what we are, what is the way we think, and we need to change the entire idea in which we do things. Okay, so to do that, we need to first understand where we come from, what kind of background we have, where have we started. So there are many people here, maybe from mechanical engineering, from many non-IT fields, even for people who are into IT, who have a basic degree in computer science. Even for them, it's a little harder to do the complete transition because you need to change the way you think, right? So that's what this whole webinar is about. How do you do that? So we come from different backgrounds, and our vision of the world is very mechanical in nature, right? The complete transition happens when you start developing a feel for numbers. Okay, so when this feel for numbers, this liking for the hidden nature of numbers, it increases, then you'll start seeing patterns, mathematical patterns. But that is where the training has to end up. So this transition, what we are talking about, from non-IT to data science, goes through these phases. Once that happens, you will be in a position to make sense and rightly appreciate the kind of data that is in front of you and be able to say, yes, this is what I want, right? And with that comes the final goal that you are required to achieve, that is become either a data scientist or a data analyst and be able to see the reports, predict, and make a lot of money for your company and also save a lot of money for your company. Okay, so with that, I want to formally welcome all of you now. So here's the thing, the PNGs and the graphics and the videos that you just saw, all of them were taken from platicon.com and bdz.com. Okay, so let's see. So we are Analogica. We have just about a year ago begun our training vertical because we realize that the way the world is going, entire landscape of education is going to change. People are going to be required to skill up at a rapid rate, and with that in mind, we wanted to be in this space. So our philosophy is to ideate, analyze, collaborate, build, and then evolve. Okay, so that's the way we want to do it. And I am Vijay C. Shantagiri, and I am a data scientist, a mentor, and CEO of Analogica. Right, so we are here to do the transition into data science. We all know that you're from a certain past, and I would say it's non-IT. And usually the hurdle to get past is this programming and statistics. even for people who are good with programming, they are going to find it difficult. I wouldn't say in a sense of demotivating you. I would say it in the sense of alerting you not to take this particular aspect lightly, because the entire data science depends on an adherence and that appreciation for this field, what magic it brings to analysis. And Mamta Navaria here has asked me if I could discuss some hands-on examples. Of course, this whole webinar, the third point in the webinar is we are going to do live COVID prediction. I have all the data of India's data till yesterday, and I'm going to build in front of you a model that will predict what will happen tomorrow and a week later. All right, so we'll do that. We'll come there slowly. Okay. So let me just, I thought this is an interesting story I would want to share with you guys, because I'm myself not from computer science. Okay, so I want to tell you my story as to how I became a data scientist. Right. So, I was working as a space systems engineer. This is way back in 2014. And I was very much interested in space, and I did the best, hoping someday that I'll be able to become a rocket scientist and meet some aliens, blah blah blah. And yeah, that's dreams always there with people. But my work mostly was into C4ISR. Okay, so C4ISR stands for Command, Control, Communication, Computers, Intelligence, Surveillance, and Reconnaissance. It's a big word. A lot of people work on it. I cannot work on it all by myself. But what I did work on is mostly into communication, computers, and intelligence. So this is how we worked, and what we did is to write programs that will connect satellites with the other assets that we call. All these things are moving, and in real time we have to ensure that this data reaches what we call a war theater. Okay, so there'll be decision makers sitting and observing how the data points are moving and what the radar is their feed, what feed the radar is giving, and what are the immediate decisions that needs to be taken. Well, this was way back in 2014, and I worked with a lot of establishments, and I was able to do that because I am a certified developer and a systems engineering professional for STK. STK is a systems toolkit, a world-renowned software suite for spatial temporal information systems. So it's a big word, but it is not as fancy. I mean, it is good, but when you break it down, it's very simple. Spatial means something related to space. Temporal means something which moves in time. Information means all the data that's coming in, and all the thing that packs up this is a system, right? So okay, somebody is saying that the video isn't clear. Let me see, bitrate, drop frames 0 here, drop frames 0. Could you please take it up a notch ahead, or increase your own volume if you could, please. Anyone else is facing issue with the audio and video, please, can you tell me? Is it audible now? I've increased the gain a little. You'd have to bear with a little bit of background noise when I increase the gain. Okay, I'm sorry if you guys, some people might be having the issue with voice, and the data frame might get dropped based on your internet speed. Make sure that you click the settings and go to 480p, because this is a live webinar. I need to make sure. I could have given that in 720p also, but the problem is that if I give it in 720p, you will always face a lag, and then that kind of dynamism won't be there. So that's the reason, right? So I want to make sure I address everyone. So here's where I was, right? I was talking about spatial temporal information system. So we worked with the ISROs and DRDOs and Army, Navy, Air Force, and the beauty of it all is that I met amazing mentors over there. Okay, everybody I met taught me something. And today, if I'm able to put together a story and talk to you guys and bring about my own transformation, it's because of these mentors. And when I say I was doing this coding and when I was doing spatial temporal information system, my work was not just to build graphical models, what you see here. I was actually interested with building the codes behind it. And the transition from here to here was a tough one. I mean, even I was in the space where I could not understand anything about programming. I realize now that I felt so because I had an inherent bias that programming is for some different kind of people and it's not for us, right? But the love that I had for my field made me go through the barrier of the self bias that we have. The love that I have for this field made me work towards it, and I actually went ahead and did that, right? So we worked a lot, and at some point of time we got associated with many different companies, and then as usual it was time for my own startup. So I did a startup in 2015 called Ubra, and it was a proprietary establishment. And with that, the first software that I wrote was called Remote Sensing Toolkit. It was a satellite-based software, and it had all the satellites in the world in the software, and you could just see which satellite is looking at what place in how much swath, and where are the assets placed, and what is the range, and what is the bias, and everything. So I thought this is a great software that I should take it to defense establishments, right? So I did that. I went to many establishments. Many people liked it, and they contacted and everything. But I have one recollection, one major change that happened in my life. It was when I went to one of these amazing defense establishment, which I cannot name for obvious reasons. And there, I went to them with my software Remote Sensing Toolkit, and I said, "Sir, I think this is something which you would love to have. Could you just take a look at it?" And there was a lot of things. He wouldn't let me in. I had to stand out in the garage, hold my laptop, in my hand, and then show him the presentation and everything. He liked it. He asked me to come the next day, right? So I went, and then he appreciated the software. But the thing is that he told me that we don't need these kind of softwares. Okay, so I felt dejected because I thought like I was in this amazing space where I could give this, but I felt dejected. But then he also told me something amazing. He said he just pointed out at the books, these books here. He just pointed out to me, and he told me that right now, if you could solve a problem for me, then we'd be interested. So the problem was completely different. The problem was not so complicated, satellites coming in, giving all the theater data. That was not the problem. There were already ready solutions for it. The problem was that this particular officer gentleman was receiving humongous amount of data from different aspects across, the whole theater scheme of things, right? The whole place is sending data to him every day, and there are events that are happening. Events, hundreds of events. This came there, that came there, that was detected, this was detected, and all of that information is put into one place, and we need to analyze it. We need to say which thing happened where, and what is the next plan of action if you were to do something about it. So with that in mind, he said, could you write me a software which can ingest all of this data and help me flag the events, right? This was the turning point for me. And yeah, of course, I had a friend, an American friend, Alex, and he had told me a long time ago that if you want to build a product, if you're not able to find any names for it, so just take the name and add X to it, right? So I followed it, and we came up with this software called FlagX. That's how it started. And FlagX could do wonderful things, right? It could take all the data, ingest, and then keep all the folders and calculate how many number of times the words repeated. It could do a lot of things. It could convert your entire text into numbers, right? Now I want to tell you something here. Look at this. Converting entire text into numbers is nothing but converting quality into quantity. Your analysis happens on quantity. Okay, of course, analysis happens on quality too. That's what sentiment analysis is, quality. But first, you need to still convert quality into quantity, right? So that is one of the gist of data science. So we wrote the software, and it also had a beautiful feature. It's called Whiskey 5 Hotel 2 Analysis, where you could just write in a certain name here, like a predator, and it would mine the data and bring out where the point is at what time and who detected it and stuff. Because this is a simple example, of course I cannot give you the detailed examples. This was just a demo example. So that's how we ended up writing this, and that's my journey. That's the story, a small story of my transformation. But let's talk about your transformation. That's what we are here for. So I hope you like the story. Give me a thumbs up if you like the story. Thank you so much. Thank you, it means a lot. So now let's talk about whether data science is actually the future, right? Data science is going to penetrate, is already penetrated every aspect unimaginable. You know why? It's because if you have a system to quantify anything that is qualitative, if you can find a system to quantify anything that is qualitative, trust me, you can apply data science on it, right? So now tell me something, because the whole entire world, our vision, the whole brain, what we have is designed to quantify stuff. That's how we see the universe a long time ago, millions of years ago. We came to this, we evolved out of nothingness, and we saw the universe, and we slowly developed. I'll come to that, the whole idea how we started from Big Bang to big data. I'm going to do a short journey, this new story over there. But let me just tell you roughly what kind of fields that we are looking for, right? Looking at in data science. So we have many different kinds of flavors of data science, which roughly is like into unsupervised learning and supervised learning, and there are many things. We don't want to get into details right now. Okay, there's a time for it. There's a context for it. When we talk about it, then we'll understand it right. Look at this. You got big data visualization, and you got structure discovery here, text classification, and lane finding on the roads, right? And then we have modeling, 3D and 2D modeling. You have pattern modeling, music generation, image classification. Look at the fields, right? You got recommender systems. You will be watching it. Okay, I just saw somebody. Okay, all right. So recommender systems. What is recommender system? You would be used to recommender system every day if you use Amazon Prime or Z5 or Netflix, Hotstar. I'm pretty sure one of this at least you'll be using, or Amazon app to purchase, or Flipkart app. There's always this recommendation which says if you like, if you like a certain product, it recommends to you, right? It recommends thing for you to purchase, right? So that is recommender system. This is huge. I mean, recommender system is business, real business. And customer segmentation, targeted marketing. When it comes to reinforcement, it's an advanced field called reinforcement learning. This is the field where we used to play this PC Man game where we used to go hunting for this weird looking. We used to escape and then collect points. Remember, from these weird looking ghost like structures in the game, long time ago. This is a game of yesteryears, and only with AI and reinforcement learning, there's a role reversal here. Okay, right now we are going to build model in such a way that these are going to be intelligent, and instead of we controlling the human being who's escaping, 5 human beings are going to control the ghosts, and we are going to try catching this human being, and human being will be controlled by AI, and AI will be escaping from us. That's a role reversement. Yeah, Pac-Man, yes, right. Rishabh Singh got it right. So this is what reinforcement learning does. We are going to put AI to test and pitch. So this is where you see people building chess engines which plays against you. It's pretty much straightforward. Everybody would have played chess online. So that's reinforcement learning. And then coming to the business aspects and banking and health sector, you got fraud detection in the bank, you got gender detection, you got image classification and medical diagnosis. And weather forecasting is an amazing field. I mean, I want to do a complete separate webinar just on how they do weather forecasting. It's an amazing feat, right? So, and then there's sales growth prediction. This is pretty much normal. Sales growth prediction is something which you can do even on Excel. This is more about data analysis. That's good. Okay. Advertising research prediction and estimating life expectancy, market forecasting, somebody who's into shares, right? So these are the kinds of things. Of course, now I've spoken about everything about future, I mean, which is not future here. So yes, data science has been the future from the last 5 years. And you would not believe data science has been around from 1950s. Only back then, people would use radars, right, to observe signals coming from outer space. Now, signals coming from outer space is not going to come to you with an input label, right? Nobody out there is sending data to you saying that, boss, this is the data for Neptune's so and so, and this is the data for a recent Big Bang that we had, right? Nobody is sending you a labeled data. You need to take this data and build models. I'm going to explain what models are. Okay, this is a new term if you're not from IT, but I'm going to explain what models are later. So people had to build models to take all this haphazard data and derive. I'm going to write this neat. Okay, I'm going to make an effort to write neat. Derive intelligence. This is what we need. Derive intelligence out of raw data. Okay, and that's where all your ML and stats and everything, this is a layer where you're going to build all these models. Chalo, okay. So before we start now, let's put our minds to context. Okay, where did we start from? I said 1950s we started, but that's not where we started. I would always want to start from the beginning. That's what has been my way approach, and I like it. And this is a simple small story that I've put up together, like just to bring context. So we start from the Big Bang itself, right? So the earliest times where time itself was zero. Time started with zero here, right? So we evolved, and also I would like to make a disclaimer here that my views about the creation and everything might differ and your views might differ. But what I'm saying is we need a certain kind of system to believe when it comes to tangible things, right? The intangible, the spiritual world is a complete personal experience. But when we're talking about things that it is going to build, predict and stuff, then we need to have a tangible system that we adhere to. So that's what I'm trying to build here. No personal comments or against anybody's belief. All right. So time, they say scientists believe that time was zero when the Big Bang happened, and we evolved and evolved and evolved, and finally from apes to the first occurrences of the Neanderthals. Okay. So when we became the erect walkers that we started wandering, there was a time when finally we realized that okay, we found a great place, let's settle down there, right? So that's when I think the first problem occurred, the problem of numbers. We need to understand. So we need to also understand what is it when you say that we have numbers here, right? Okay. So what do I mean when I say the problem of numbers? Let's say the first primitive man had a man or woman. Okay, again, no gender bias. Let's say primitive family had a farm, and there would be all these animals in the farm, right? I'm drawing random numbers. I'm not even assigning numbers to it anymore. So this person who's in charge of taking care of this, morning would open the gates, allow all these cattle, let's say all these are cattle, and allow all these cows and sheep and all whatever the animal set he had, he'll allow all this to go out to finish the grazing and come back. Okay. So now there is no number yet. How does he count? How does he or she count? So what they used to do, you will not believe what they used to do. They used to take in the morning when the gates open, this person used to collect a set of pebbles randomly, okay? Randomly used to set a large collection of pebbles in one hand, and as he sees one single cattle moving out, he would transfer those pebbles to the other hand. So once the whole of this is outside, let me get the lasso here. Okay. So when all of this are outside, he would have exactly those number of pebbles with him. So that's a reference system he would build. So what happens when he comes back, when all these are back in the evening? It is fairly simple. All he has to do is just make sure that everything that is coming back in, he transfers it back. And if he's left with any pebble, it means that many number of cattle, sheep have not come back. Right? So this is how they had the system of counting. But of course, the world changed and the minds got together and they came up with the idea of representing something with a symbol. And that's what your numbers are. Okay? The world got quantified in a simple way. And imagine something which is just single is 1, something which is just set of 2, we'll call it as 2, something which is like 3, we're going to symbolize it as 3, ... But then one of the most beautiful abstractions, these are called abstractions. One of the most beautiful abstractions was the number 0. If something doesn't exist, somebody came up with an idea, if something doesn't exist, we still need to have a symbol for it. I mean, that is why it is a stroke of genius. Because something which exists is logical to find us have a symbol, right? But the person's vision, the schema of things about universe and numbers in that person's mind who gave this number 0 was so vast that he said, no, we're going to have a symbol even for nothingness, right? And you will not believe this 1 and 0. Of course, I don't have to tell you, once I draw this ones and zeros, everyone now can just relate to it. This is the basis of computation now, right? There is something's there, something isn't there. Look at this, right? Right. So, with that, there was years later, as things evolved, and there was another problem. Problem to problem. That's how every time there's a problem, we evolve with the system. There was another problem. What was that problem? The problem was coordinate systems. So at one point of time, Dr. Sanjay Pandeyji, yes, 0 and 1 is machine learning is you'll know by the end of this webinar, you'll know what machine learning is. 0 and 1 is just symbols, and 0 and 1 is the basis of binary system. Okay. All right. So the next problem was coordinate systems. So why coordinate system was needed? Think about it. So all these families have settled together in certain places, and they're all distant, and one person is living near the seashore, and the other person is living near the hills, and the seashore people have a lot of fishes with them, and then the people who are living near the hill stations have a lot of fruits with them, right? And you want to trade. To trade between one place to another place, you need a system to travel. And a system to travel in primitive times was a map, right? You need a reference system and a map. So to achieve that, to have the right, because now I'm talking very simple, but actually the trade happened at a large scale. And when I say large scale, we're talking about thousands and thousands of kilometers and ships traveling. And you definitely needed a system over there, right? Okay, so with that in mind, they came up with the coordinate system, Descartes. Descartes was the mathematician, okay? Descartes, French mathematician who came up with the coordinate system, and that is why it is called Cartesian coordinate systems, right? So that's why it is called Cartesian. All right. Yeah, this Descartes. Yeah, thank you, Rene Descartes, right? Perfect. Yeah. So now they had a very nice representative system. They would say, let's have axis here and here, and let's have numbers all around this place, and then we will be able to exactly map where these points are. And then I can say you move point this x1 comma y1, and then move it to some x2 comma y2, and this is the map you have to follow. And while you're coming, the north should be on this side, and the so north star should be on facing this way, and you have a system to travel, right? So you're understanding how we started with problem of numbers, then coordinate systems, right? Then there was another problem. And this problem was about the smoothness of curves. The smoothness of curves, when I say smoothness of curves, I tell you what it means. Let's say there's one family, another family, who've got places in different, who's got something to trade between them. And here we're talking about trading land. So if you want to calculate the area of this, what would, let me say, this is the length and this is the breadth. What would be the area be? Formula, you know, everyone knows that, L into V, right? This is the established formula. There is no confusion about it. If you put this many lengths, this length, breadth number of times, that's area, right? Fine. But if this person wants to trade a certain piece of land with this person, right? Person 1 and person 2, right? And let's say the land looks something like this. Now, where's the length and where's the breadth here? How would you actually have a measure? I mean, you can just see, okay, there's this place, so I'm going to trade this land to you, and you might as well just send 2 sheep and a monkey with your pet with me, then we are even. Okay, this probably worked back then, but there were, of course, always some people, some genius who would not agree, who would not be happy with, satisfied with that. So now I want to perfect. You can use rope. Great. But what if you are a king and you want to trade villages? How big a rope are you going to bring? Right? I mean, there's always a reason for certain this one to come into picture, but a rope idea is a great idea. We can always use rope. That's brilliant for a small piece of land. But when it's a huge piece of land, and there's also something else. This is just an example that I came with, but there's something else. I'll connect that. But then tell me, if there was, yes, Jairaj is right. Mr. Jairaj, yes, birth of calculus, integration, yes. As you can see, what we talked about here until here was algebra. The relationship between some abstraction with another abstraction. X is an abstraction, Y is an abstraction, there is a inequality, a linear relation between them. But when the relation is not simple, that's why it's got smoothness of curves. There was a beautiful book on calculus called The Unbearable Smoothness of Curves. It's a beautiful book. So that's where I took the name from. So to achieve this, calculus came in. Now there's an interesting fact I'm going to share with you. You know why the United Kingdom or the Great Kingdom of England, it's called that this is the kingdom which never had a sunset, right? The kingdom which never saw, the sun never set on the British Empire, right? Sun never sets on the British Empire. It's because British Empire was spread everywhere. And that was so because, why was it spread everywhere? It's because they used to have all the ships with cannons on them, right? And Newton, being the first person who would exploit this, would get the maximum range possible for their trajectories, right? So when you have another Dutch or a Portugal ship here, then this would need to come all the way further to get that trajectory. But for them, once they have it in their range, they would destroy them. That's how calculus achieved that quality. They gave that quality to the British Empire, the engineers and the technicians and the cannon masters of British Empire, to set it up perfectly, and that's how we're all speaking in English today. If Dutch had got calculus before the English, then we'll be speaking in Dutch, and I don't know, maybe Dutch wouldn't even rule us. But the idea is That's how mathematics influences world we don't even know about. So the whole summary of it is, I'm building your interest, your motivation, and your appreciation for mathematics. All right. And days and years and everything passed by, and somewhere I think in 19 not 1900s, I think hundreds, there was this pure mathematician, right? They're called pure mathematicians. They don't know why they are doing it. They just see beauty and they do it, right? That's the beauty. And back then, his name was George Boole. Yeah, Boolean algebra. Yes. So that's what he created. The person didn't create it because he knew computers would come up. Okay, there was no chance that he would find out later that somebody would put together some vacuum tubes and use those ones and zeros. It was just a beautiful system, and he said, why now? Why do you need 1, 2, 3 and all that to compute? I'm going to just express it with just two symbols, 1 and 0. Everything, all these numbers he reduced to 1 and 0, and he paved the foundation for digitalization of information. So understand, when I say digitalization, of information, it's very important. Because of this, we have this advent in data science today. And then years passed, from ages from 1940s, 1925s, already the idea of computation had begun, right? And then years passed, and then we landed in around 2005s, where amazing computational power, really commendable computational power, was bestowed on because of the huge advent and research and development in technology. Now each one of us, or all, some of you guys might be viewing this entire webinar on your smartphones. So with that power of computation, smartphones came in, and then boom, we started generating data at an unprecedented rate, right? Everybody is producing data. I am producing data today. Your comments is data. The 3 dots top right corner and somebody saying hi, video not good, everything is data. If I want to analyze this, if I want to just use a sentiment analysis and go through each one of your text, and I can say whether this, I don't even have to ask you, I just can take the text and use sentiment words, the good words, the bad words, and I can have a rough estimate of how good or bad the webinar was. I have a lot of data I can show you maybe later, that's been collected from all the superstars channels, right? Superstars have their YouTube videos, and people comment this, that, and everything, and then there's a classification model that we build to remove all those spam data. So that's what it is. That's what it is about. I spoke to you about the future, whether it is the future. Now it's up to you to think whether the amount of data that we produce, is it going to increase? Yes, lot of data is going to increase. They are even going to increase the breadth of the application areas. I mean, there are certain application areas which is still being researched. Okay, one second. Just a minute. So these application areas are going to, one of these crazy application area that I was, if you guys want to check out, it's ICRISAT. So this is a purely agricultural aspect, trying to understand and predict what kind of insects are going to spoil the crop based on different kind of weather patterns. Prerequisite is doing amazing work, and so this is something which is good for the world. Okay, if you can get control on food, shelter is always there, but if you can just get this in order, right, I think we'll have a lot of peaceful times in the world. So having said that, now let's go ahead and understand what is the expectation from the industry. What do you expect from data science altogether? So we now shift to positions, skills, and salaries in the field of data science, right? So basically, the umbrella terms which I can classify, in a sense that can give perspective as to where you fit in, where you can fit in. If you're a beginner, what to aim for, and if you're aiming for this, what is expected out of you, right? And where does it go? So we're gonna figure that out, and you can see the first one here is called the machine learning engineer. The second one here is the AI engineer. There's a difference, okay? The third one here is the data analyst. The fourth one is actually the quintessential dream of everybody. I mean, this is okay, this is data scientist. Data scientist term, the tag, I think it's a phase that you'll never get to. Okay, any person who is always trying to become a data scientist, he's the data scientist. If you think you've become a data scientist, then I don't think that's the way it is, right? So an actor is always a person who's trying to act, is trying to become an actor. So you're always appreciating he or she is trying to become an actor, so trying to become a chef. So when you say transition, now let me come back to what I was trying to. Transition from non-IT to data science is not transition from positions, right? It is a transition of the process of thinking. But the process needs to be continuous. Now, what kind of processes we have for machine learning engineer, for the other things that I was speaking about. Now, I just hope it's clear on this one. I might even increase it if you want. Let me increase it. I have enough space to write. Yeah. Okay, so far, am I audible? We are getting into sort of the business end of things now. This is important that you guys you don't miss this, right? So machine learning engineer, entry level packages that you can expect is of roughly about 8 to 12 lakh per year, and experience is from 1 to 3 years. And if you are 6 months experience, you're not going to get there. You need to show at least 1 year of internship, 1 year of some experience somehow, right? Experience means not working for any company where you get paid for it. Experience in the sense that you've been doing some projects, building portfolios, and letting those projects out there for assessment. Some third person, some third body is able to understand and appreciate and assess and evaluate your models, right? So if you can do it for 1 year, then you have 1 year experience, and then with 1 year experience you can enter machine learning engineering position. Okay, what do you need for it? Programming skills. I have just rated it as how much of it is required. For a machine learning engineer, you need a moderate level of programming knowledge. Nobody is expecting you to build engines or packages and stuff. You just need just simple moderate level of programming. But the knowledge of pandas and Python packages, I'm not saying building package, using Python and pandas packages, these pandas and Python packages are the most important aspects of a machine learning engineer's bread and butter. Pandas is what? Pandas is, I'll tell you, if somebody is able to follow, I'm going to tell you what pandas is. Pandas is a package. Okay, what package is it? It is just the Python equivalent of Excel sheet. Okay, In Excel sheet, you do a lot of formula building and stuff to take this data from here and that data from here, correlate everything together and do it. But if you want to keep on repeating something in loop, then the equivalent of that Excel sheet and with the Dhruv Bansal here is just a data manipulation tool. You can say that, yes, data manipulation framework, you can say, right? A part of Python. You call import pandas, pandas come, you can access it and put all your Excel sheet data into that immediately and do a lot of magical stuff with it, right? So then you got ML algorithm skills. When I say ML algorithm skills, you need to know, as a machine learning engineer, you need to know machine learning algorithms. But there is a level at which you need to know certain algorithm to be able to tweak something, to be able to combine 3 or 4 algorithms together to achieve a certain result, right? So that much of prowess is not required for an ML engineer when you're entering. So you don't have to sit and wait and say, I'm going to read up everything and then I'll apply. So that positions that you're looking at, it's not required, right? So a moderate level of machine learning algorithm skills is required. And there is something called the OOPS concept, object-oriented concepts in programming language. So when you're writing a big software, like we were writing FlagX, we wrote this. Now we are converting this FlagX software into purely Python based, because that software that I wrote a long time ago was completely written in C# and pandas wasn't even there. You can see what we did there in FlagX that I showed you earlier. We have not even used Python there. We have not even used C#. It was a long time ago, right? So I had to hard code everything. And I and another close friend of mine, we together built the software, and even the simple computations, we had to write those libraries and APIs and put together the whole thing. And we enjoyed it, definitely. That's what gives us the power to imagine today. But yeah, so coming to OOPS concept, if you are not, as an ML engineer, you're not going to be building big software. You will be, of course, a part of the team which wants to build bigger and enterprise software. But nobody's expecting you to know complete OOPS, right? It's not like a computer scientist that you need to know the whole of it. It's something which you learn as you evolve. Now, let's understand this. Intuitive mathematics. Now, when I say intuitive mathematics, I'm not asking, or nobody will ask you if you can remember a particular formula, right? You need to know the gist of the formula. You need to know the form of the formula. Formulas and data and what to do when you get stuck, everything is available online. You just need to know how to Google for particular information. It is right there. Okay, there are communities sitting there and developing this whole infrastructure for people like us who want quickly something, and we get it. But the question is, how will you Google? Because if you don't know the concept, you will not use the right words. And if you don't know the concepts, you will not understand which one is the right answer, right? So don't be so hard on by hearting and stuff. Not required. It's an experiential process. So minimum intuitive mathematics required, and inferential statistics is something inferential, right? There are two kinds of statistical paradigms when it comes to machine learning. There is something called inferential and something called descriptive. Descriptive is something which defines something. It says that there are so many COVID cases in India today. Okay. But if you are trying to build a predictive model like we're going to do later, it's called inferential. You can infer something from the data. Can you infer something? Can you build a model that we can infer something? That is inferential statistics. For a machine learning engineer, both inferential and statistics, descriptive statistics, the level at which you require is moderate again. You don't have to really break your head on it, right? So next, for a machine learning engineer, the big data and Hadoop framework. Because even though you'll be a machine learning engineer, fine, but still you will find yourself in positions where you will have to handle big data, right? So you don't need to be a person who will install all this big data and maintain it, but you definitely have to know your way around these concepts. So we combine all these things in the level that I spoke about. you're good to go with the first positions of machine learning engineer. Now AI engineering. What is an AI engineer? Let me increase the visibility. Hope it's clear now. Yep. Right, AI engineer. It's a little different. AI engineering is a little different. When you're trying to build a system wherein you are trying to achieve a human-like intelligence. Where are this human-like intelligence? Self-driving cars, right? Human-like. Can you give me some other examples? Human-like. Something which says you want to replace humans. Robotics, yes. Can we have one more example? Humanoid robots, Alexa, yes. Bingo, going well. Androids, the androids from sci-fi. Smart parking, yes. Yes, it's human-like, yes. Another, anyone else? NLP, Neuro Linguistic Programming is, yes, because let's say I write Alexa here, and to achieve Alexa, you need NLP. Yes. Google Assistants, yes. Fuzzy logic is a paradigm like machine learning. Chess games, yes. Fuzzy logic is a different kind of algorithm. Customer service. If you are saying customer service, simple example is okay Google, yes. And material science structure simulation, you can use human-like, but it's not. I don't know. When I say material science structure simulation, somebody has given. I don't have the data to comment on it right now. I have to think. I'll get back on that. Okay. The chess games, material science, simplest example, Google Voice, yes. Chatbot, definitely yes. Chatbot is again connected to NLP. Neural network is the Mr. Amir Ashraf has commented. Neural network is the means to achieve AI. Okay, like car is the means to go to your office. So neural network is the way to achieve AI. Industry assembly line robots need not be human-like. It can be achieved with just industry assembly line robots need not even need machine learning. A properly written nice software can achieve that, right? All right. So I think you guys get the whole point. You get the whole idea. Now you should now what I'm going to tell you, you will start appreciating it, right? Of course, you need programming skills. Look at this. Programming skills I've put it as very high. You need high programming skills. And that is why the package itself, once you finish 3 to 4 years, where do you jump in? You would like to look into AI engineering. Package is roughly from 15 to 22. And I think if you can really do well, and if you get into the right space, easily up to 30 lakhs per annum, right? They're headhunted actually. So programming knowledge required is very high. Pandas and Python packages very high, not very high, but of course to a certain level high. ML algorithm skills high. You need to be able to tweak and do some changes. Use many things called ensemble programming, where you use many different algorithms together and you achieve something, because your goal is to achieve human-like intelligence, smooth intelligence, right? Of course, when you are writing programming, complicated programming, of course you need object-oriented programming at a very high level. Object oriented programming at a high level, right? And of course, again, back to intuitive mathematics, moderate, not problem. Inferential statistics, moderate. Descriptive statistics, also moderate. Big data and Hadoop, also moderate. But domain knowledge, look at this, a new term here, domain knowledge. This is for the domain knowledge people. Now, this is for you. This is for you. You may be from non-technical background, but you are from some background, right? This is where you hit the jackpot. Anybody who's from non-IT, you hit the jackpot. My background was space systems. Okay. In fact, I talked myself into that role when I spoke to my first boss. Said, I am qualified to understand these systems. And all I need is to just give me that system here and get me certified in that, and then boom, I know what to apply. Right? So you might be from different fields, from mechanical, from electronics, communication, management. Everything is a domain. Now, if you combine all of this, your domain prowess with machine learning algorithms, and have put a lot of effort in programming, and then understand inferential and differential descriptive statistics, you are actually looking at AI engineering. Of course, you have to go through ML first, ML engineer position, then you have to complete. But domain knowledge you already have. So don't think that you can leave what you have been studying or doing so far and simply get into that. That's not the way. You need to explore how you can apply ML and AI into your own field, because you have the domain knowledge in it, right? Because right now I may not be able to completely give the perspective to you why domain knowledge is important. Because if you want to do any analysis with the domain that you have, you need to be able to put that information that you know about the domain in the algorithm and evaluate it. If the algorithm says something else, if the result says something else, you can always evaluate saying that this is not expected, because I know stuff, because I am from automobile background, I know this cannot happen. So immediately you can identify there's something wrong, right? Domain knowledge people, lot of respect and appreciation for them in the industry. Okay. Right. Next is data analyst. Now, data analyst positions are for those who just cannot overcome the barrier of programming. And data analyst is also for those who've had a lot of experience and they don't want to get into the nitty-gritty of things, programming again, and sit and do a lot of coding day in and night. Programming is a very spiritual experience. If you get into the zone, you don't want to get up, right? If you don't get into that zone, that's when the biggest problem is. So transitioning from non-IT to data science is to get you and appreciate into that zone. Okay, somebody is asking me feedback form, sir. Okay, somebody is already ready to give feedback. I think I'm reaching 5 o'clock, but I think this webinar is going to go a little longer than expected because I'm getting into too much details, right? So I'm going to give you a feedback form, and after you fill that feedback form, you're going to get another form based on all the questions that I have here. I'm going to give you another Google form. If you take that small questionnaire, finish it, and then you'll also get a certificate from us, right? Because you put a lot of effort listening to me, listening here and sitting here, commenting. That's an effort from you guys, right? So for that effort, I want to appreciate that with an effort, but I'm not going to simply give you a certificate. I'm going to assess whether you understood anything in this webinar, and I'm going to keep a 50% cutoff on that. You can retake it again and again until you get the 50% cutoff. And then once you get that cutoff, and you'll get an email. Okay. All right. So data analyst, you don't want to program, you just go at some tools. So let's see what skills are required. Of course, see this. Package is still not less. Just because you're not programming doesn't mean that you're going to get paid less, right? Because you still are looking at something that's 15 to 20 lakhs per annum. Although programming knowledge required is next to nil or minimum, pandas and Python packages, you don't even need to hear about it. ML algorithms moderate, even low, I would say. OOPS concept minimum, but intuitive math high. Inferential statistics high. Descriptive statistics high. Tools like SAS, Tableau, Excel, all of this should be high, right? So this is where you need to focus on if you don't want to program. If you're from a purely non-technical background. One is non-IT, one is non-technical, right? So non-technical people suddenly to take them from technical and then to IT, too many bridges to cross, right? So with that in mind, I would say if you are looking at the position where data is given to you and you have to use different tools to build a model which already uh, exists in the system, which is already like you need to be able to know how to exploit that tool correctly and build the model, right? So you can understand that you'll slowly start appreciating why these are all different, because for some business decisions, this is all that is required. This is good for them. That's it. They don't want you guys to program in Python and put it on cloud and make a real-time feedback analysis. Nothing they want. They just want, I'm going to give you tons of data and you're going to derive intelligence out of it and give me what to do next. For that, Tableau, Excel, SAS, many tools. Even we are trying to build a tool called FlagX for it, right? So that's how it is, right? Next, what do we have here? The quintessential, the prime motive that everyone wants to become, but nobody seems to be authority on it, right? So that is data scientist. So I know I said that I am a data scientist, but I am a data scientist in the making. I feel you never are a data scientist, because every day amazingly brilliant people are coming up with awesome new algorithms, ideas, platforms, and you'll never have your fill, right? So a so-called position of data scientist earns roughly about, in a moderately sized big company, would earn roughly about 30 to 45 lakhs per annum. But for this, you require 10 to 15 years. In 10 to 15 years, imagine so many problems they would have solved. And at a data scientist level, your programming knowledge expectation is moderate. Your pandas and Python expectation is moderate. Can anyone tell me why for a data scientist it's moderate? Why the data scientist is not expected to know amazing programming and a lot of pandas and Python skills? Can anyone just comment on it? Why you guys think, or why is it so? Why I think like that? In fact, all your answers are true, but I'll give you a very practical answer. Okay, all your answers are true. I'm not saying it's false. All answers are true. Practically, the practical thing is the data scientist is paying 8 to 10 lakhs to a machine learning engineer. That's his job. Because the data scientist is never alone. It's always a team. Right? So the machine learning engineer who's there in the team is going to do all this. They'll require this. The AI engineer they'll do all this programming skills. So it's just basic stuff that you require to be able to guide your ML engineers and AI engineers to get the whole thing done. But what is required highly is algorithm skills. When I say algorithm skills, I'm not saying computer algorithms, right? Computer algorithm skill will be taken care by AI engineer. I'm talking about machine learning algorithm skills, right? Machine intelligent algorithms. So these algorithms, of course, with 10 to 15 years, if you've been doing it for so long, of course, your knowledge of it will be very high. Next, what is it? Mathematics, of course, high. Everything that is in this kind of blue is high. Everything that is in red is very high. And this blue color, the sky blue, is moderate. So inferential statistics, of course, high. Descriptive statistics, of course, high. And then tools also high. Okay, so there are many aspects. Data scientist needs to know a lot of stuff, but still there is there are certain things that is not expected of a data scientist. Okay, all right, let's move on. I'm going to go a little faster now so that we still make time for all the things that I have put together here. Okay, now the next question, what kind of background degree is required to achieve the transition? The background degree, I have a funny story here when you say a background degree. We have all these degrees like computer science and mechanical engineering, and in all of that we have 4 years and we have 8 semesters. 1, 2, 3, 4, 5, 6, 7 and 8, right? We have 8 semesters, out of which first 2 semesters are common. The last semester is about project, so we are left with 5 semesters. So in 5 semesters, you have 6 months roughly, but it is actually it's going to be 4.5 months. So that's roughly about 100 days of work. Okay, 100 days of work, 100 days of study in a semester. Give or take, remove all this holidays and your festivals and fest and all the other engagements. You're now left with around 60 days where you actually attend like a so-called graduate of a certain stream. So you're looking at 60 days a semester, out of which, tell me honestly, are you going to study all 60 days? No. Let's take a rough estimate, an average estimate of India. 30. So you have 30 here, 30 here, 30 here, 30 here. Fine, you got 30, you got 30. This is how much we study in a semester, right? So your basic study is what? 1, 2, 3, 4, 150 days to be called a certain engineer. What the point I'm trying to make is, if you got a bachelor's degree in something, that degree means nothing. It's a requirement from the industry. It's a proof that given a task, you have the aptitude to conform to a certain discipline. Your teacher has asked you to do something, you did it, and based on the number of people, the students you had, you were at a certain level. This is what it means, right? It means a lot other things, but it has no relationship with the domain that you're coming from. You can be any engineer to come into this field. But to become something, to become a professional at the level of becoming a consultant is someone who consult, is a domain knowledge expert, right? It's said that you require 10,000 hours of work for someone to become this. 10,000 hours, literally 10,000 hours. I don't know, it depends upon how many hours you can give in every day. So based on that, you can calculate how many years it will take for you to become an expert in something. So this is the general norm. If you put in 10,000 hours on something, you're really at cutting edge. You're really a consultant. If somebody gets stuck, they'll come to you, right? So with that in mind, what kind of background degree is required? No background degree is required, but effort is required. Now let's have an intellectual prerequisite that is required. Intellectual prerequisites. And there is something about IQ, there is something about TQ, technical quotient, intelligence quotient. So the requirement is you need to have a mathematical and logical mindset. Okay. When I say mathematical and logical mindset, what I'm trying to say is, we have this COVID situation. Somebody asks, what happened to this world, man? It's all bad karma, dude. That's not mathematical and logical mindset, right? Maybe at a spiritual level, yes, it is, right? But to answer a quantified question with an unquantifiable answer is not having a mathematical and logical mindset. So you need to make sure that what is the question, and you need to mold change and be able to garner all that intelligence in you to put your answer in that structured way. That is the mindset I'm talking about. Okay. Make a note of this in your own mind. If you don't have this, then you need to build it. Okay. Let's go to next. Behavioral prerequisites. Behavioral means it's about you, the person, what kind of person you are. For data scientists, it's a research-oriented field, right? So I'm going to take this, and it's a teamwork. It's not a single person. Nobody sits alone. Yes, they do, but very small for a small data set. But it is really a cutting-edge thing. When you're building something which can be scaled and made into a product and sold somewhere, it's got to be teamwork. So teamwork is something which is common everywhere, and it is common here too, and more here. And you need to have a scholarly approach, right? When I say a scholarly approach, I don't know what to define for an unscholarly approach. I don't know what unscholarly approach is, but I definitely have an idea of what scholarly approach is. You approach a subject in a very structured manner. You have a system of approach. Given a new thing that you want to do, you suddenly simply don't try to find a code and put together. No, you have a system of, you'll collect all the data. Maybe you'll collect all the papers written on it. Maybe you'll talk to somebody who's already done it. You'll communicate, email some people, right? That's an approach. That's how scholars approach, right? So you need to have that kind of an approach. Patience. Too much patience is required. And with this patience comes skill, right? The more patience you show in the beginning, the less patience you need as you move along. I hope you're getting the idea why it is important. Because the more patience you show in the beginning, more patience you have in the beginning allows you to stick to that problem, and your neural structure will change, and it'll give you the spark, the insight to the problem. Right now, what I'm trying to say is, we are of two divisions. One is us speaking to each other, and one, there is a subconscious structure to us. Our actions influence that structure. Now, if we are the kind of people who don't have patience, we'll never allow our structure to change. So patience by far is the most important aspect, behavioral aspect required to undergo any kind of transition, I need to have a rigorous approach. A rigorous approach means, if somebody gives you data and then your client says, sir, it's okay, just give me 90%, 95% fit, we are happy with it. And if you are saying, okay, cool, if the client asks so much, fine, right? If that kind of attitude is there, then it will be a little difficult in the beginning. Maybe later when you're really pressed for time and you want to just give what the client wants, that's different, that's a business decision. But in the beginning, if you are meddling with certain data and you got certain result, and you say, hey, I got 90%, my father always said, get 90% in the school, I'm happy. No, 90% is not enough in the real world. Means when I say 90%, I say 90%, the accuracy of the model is 90%. Means out of 100 times, 90 times I will predict right. Will this work in car driving? No. I want 100 means 100, it should not have an accident. That is rigor. Rigorous approach means that. So depending on what kind of field you are in, AI or ML or data analyst, the definition of rigor will change. So that's about it. That's the behavioral aspect. And then you have experiential prerequisite, that is a domain knowledge. You have to have some kind of expertise in some knowledge. It can be an expertise in ML itself. If you're an expert machine learning engineer, then you're an expert. That's your domain knowledge, right? But if you're coming from different domains like automobile or electrical or finance or medical health, right? So that's your domain knowledge. Now, how to choose a course? It's very important to understand how to choose a course, right? So choosing a course for your transformation. Now, you don't choose a course, you choose a mentor. And mentor has certain qualities that you would be wanting to aware of. And the person or the mentor should always be motivating, right? And should have the compassion to understand the nature of obstructions a person who's achieving a certain transition is facing with, and leads by examples, right? So more than anyone else, that mentor should be able to, or should be going ahead and solving various different kinds of problems. And then that mentor should entrust you with hard problems and guide you to solve it. There's no way you can just be given small, silly problems and then you solve it and then you say, okay, I know machine learning. The mentor should always put you into a hard position and then make sure that there is always a lending hand, a guiding light to make you move through it. Then you know how to move or get yourself out of difficult situations of that particular field, right? So with that, another added statement here is to make you achieve small successes before moving to higher level problems. You take step by step. And of course, the main hurdle for transitioning is programming and statistics. Programming and statistics. You choose a course which is intensive on these aspects. Trust me, there is so much free material out there on machine learning that if you get these two things right, then the free material on internet, I guess, will be enough for you to get ahead of the curve. But how do you understand, how do you get this transition? How do you become professional, right? That's the question. So I have a system for it. This is what we call taking advantage of vernacular languages. So there's this fact, not a story, it's a real fact, that China, Germany, Japan, and all the major powers, the students study, in their own language. Okay. So when they study something in their own language, the understanding is faster, quicker, and deeper. Faster, quicker, and deeper, right? So I would also suggest and appreciate if you guys can find material which are in your own language concerning programming and statistics. The first shot, if you're a Hindi speaking person, then go find that Hindi tutorial on Python. Somebody who's going to explain everything in Hindi to you. Everything explained in Hindi, everything about statistics explained in Hindi. Or if you are a Kannadiga, do it in Kannada. Goan, do it in your own language. I don't know if every language has it, but most predominantly, I think Hindi speaking people are more, and definitely I've seen a lot of videos on, but not premium videos, but we are coming up. We ourselves are coming up with a purely statistical course explained completely in Hindi, right? So that way you don't waste time. The amount of time taken, let's say if it is about 1 year to completely attain that mastery with a lot of ups and downs, that can be reduced to 3 months because the focus is so intense, because it's faster and deeper. And what was the cue? Forgot what the cue was. It's faster and deeper, right? Quicker, yeah. Faster, quicker. Faster and quicker is sort of same, but I would just say QD then, quicker and deeper. All right. Yeah, it's the same thing. Yeah. In the flow it happens. All right. Now, free versus paid courses. So what's the dilemma? Now we have to understand whether you are resolved enough to find your own way out of the maze. Because believe me or not, when you are going from a transition, the transition is this phase, this maze phase, right? Now there is no way of telling how many days it's going to take or how many months it's going to take for you to achieve that kind of comfort. So something which looks like this in the beginning, and it slightly looks a little complicated, and then you have the third phase, slightly more complicated, and you still think you're in control, that okay, there's just two cubes just moved like this and a third cube moved like this, but quickly within no time, so the same problem which you were trying to tackle, the same problem which you thought was in control, but if you don't have a proper guidance, quickly you're out of control. I mean, that's demotivating. So the difference between the paid course and the free course is that something which gets paid comes with a commitment. Okay. And also the definition of what is money. You're paying with money, but are you actually paying with money or are you paying with time? Because in today's generation, it is time which is money. So there's this beautiful quote which one of my first bosses who told me when I was very young and I was whiling away my time. Then he came to me and said, everyone has to pay, but we pay in terms of what is of least consequence to us. I mean, something which is of least consequence will be the currency of your payment. If you have more time, means if you have more of something, it is least consequence for you, right? So you'll pay in terms of time. So if you have more money, you'll pay in terms of money. If you have more energy, you'll pay in terms of energy. Now it's up to you to decide which one of this can be earned back. Can you earn back time? Can you earn back money? Which one? It's up to you to decide. Okay. So between free and paid courses, the choice is completely yours. I've just given you the way to think about it. Okay. Next. This particular piece of information I have here is I'm going to share this. Okay. I'm going to share this because this is important. Because having said that paid and free, I also want to guide you to some of these amazing free stuff, right? Free stuff that is out there, and you can just subscribe yourself to a channel called 3 Blue 1 Brown. Beautiful channel. StatQuest, amazing channel on statistics. Andrew NG's course on Coursera. Udemy has a great number of courses, but they are not live, right? They are all recorded courses. So if you can follow through, definitely. But most people who come to our courses, they come from having done all this, but still they find some amount of clarity missing, and they come to us with expectation for that clarity. But definitely great options. And articles on medium.com is a new revelation in content for machine learning and AI. Okay, it's content. These people have premium content written explicitly well for consumption of beginners. Okay, and same thing is true with Analytics Vidya also. They also have a great setup and a system. But in summary, you go and find any program that is sponsored by Patreon. Okay, so this is a group where best of the material gets sponsored. Patreon is a platform where people pay for these kind of great people to continue, right? So 3 Blue 1 Brown sponsored by Patreon. StatQuest, I don't know, but I'm thinking it's also sponsored by Patreon. But so these two things are a must. You should and must subscribe to these channels on YouTube. I'm going to send the link for all this to you guys. Next, transition. Under transition, the question is, should you go for a complete course where they say, hey, come join our course in 1.5 years of this PG diploma. I'm going to completely transform you from non-IT to data scientist, or whatever. Now, think about what happened the last time you did this. Were you transformed in 4 years of your graduate degree? Were you transformed in the 2 years of your masters, right? So the idea for transformation or transition has to be smaller jumps, because you need to wet the field. You need to get the feel for the field. So go for small courses in the beginning, small certifications like a small webinar, a small workshop, a small certification, right? Then when you assess the field and you find yourself comfortable to take up the bigger load of these 1.5 years diplomas and big masters, then you're ready to actually earn that degree. Okay, I'm not saying this is no, this is good, but you need to know when to get into these kind of big programs, because big programs will have a huge syllabus and there'll be time, and if you're not the kind of if you're not a completely free student you will have to work 2 shifts, then smaller jumps and smaller courses are the courses for you. Now, next is question to ask. Does your course give you a platform to create your own portfolio? Because a portfolio is very important. Once you finish a course or anything, to come into the radar of the recruiters, you need to have your portfolio, like what you've done, proof of that, how you solved it, right? How you solved it, what have you done? So all of this, there are platforms ready. You just need to know about, and your course or the mentor or the institution should be able to get you to get here, get you to have your own portfolio and not fake it. Today's data, this AI generation, in this generation, it is easy to detect fake and fraud. Okay, so there is no way you can fake a portfolio. It has to be genuine, because the effort that you're putting in might be for satisfaction or for money, right? Your dream. If you have fake portfolio, you're gonna have fake satisfaction and fake dream come true and fake money also, right? So this word has to go. There is no fake. So careful when you're choosing a course. There are many courses in the market which is aimed particularly at undergrads, because undergrads have this requirement from the university that they need to get some internships and some certifications. They have at the university level they have a lot of formalities, and there are many institutions which have sprung up just to fulfill this formality without giving much of an effort, much of a load on the student, right? So I would call it in a way, I would not be too derogatory word or like fake on them. That's a necessity, and they are doing sort of business. But they still, the undergrad at that level still do learn something, but it is definitely not for a professional transformation, right? It's no these kind of courses. You need to be aware. I don't know how to identify those courses, but if you are putting in your time and effort, you have to have a system to identify it by talking to them, understanding stuff, right? All right. Now choose a course where the system, the instructor, the institute believes in assessment and not just simply giving you lessons. Okay, assessment, most of the, even my students, they sort of don't like this idea of assessment, because I do keep a lot of assessment every time there's a quiz, there's a questionnaire stuff, and as things get harder, then they would require more time. But there's always that balance that we have to have between how much to teach and where to start evaluating, right? But there is no transition without evaluation, right? Because who's going to evaluate you? There has to be some evaluation. Why? Because knowledge is free, but exams are expensive, because evaluating someone is time consuming. It's not like I do this webinar and there are around 40 to 50 people listening to me. But when it is evaluation, I cannot evaluate all 50 people at once. Even though I write a small program which is going to just tick the questions that you sent, that's not enough. Evaluation is not just correction of papers. Evaluation means sitting with the person and understanding that you wrote this wrong. This is what you got wrong, and this is how you should think about it. That is a one-on-one thing, and it's a time-consuming thing, right? So make sure that it is not just this evaluation. This kind of things might not happen with programs on Coursera. Yes, they do. Udemy also, certain mentors we get in touch with, they definitely do. But always choose something where there is a small batch size. Books to read. If you want to start understanding, okay, if you want to start with something today, I would say these are the two books that you need to invest. One is Statistics Without Tears, another one is Predictive Analytics by Eric Siegel. Both of these books I've read, and these books make the cut. They're really good, and make sure that you I'll even send you the link for this, and it is going to help you. This book is going to help you to understand how problems are solved in predictive analytics, and this book is going to help you understand statistics without bothering you and boggling you down with numbers, because this is what you need to achieve first. So, and then of course you can find a lot of programming and analysis and stuff, free courses as well as paid courses. But the effort to get from the non-IT framework of your mind to programming is the most fundamentally important thing before you think or you call yourself a machine learning engineer. Without programming, without the power of automation, without the knowledge and the tool for it, you cannot do the transition. So make sure that you get these aspects right. All right. So now let's come to COVID prediction. Okay. So when you are trying to predict something, first you need data, right? So we do have that data. I went to Worldometers. Of course, you guys might be knowing worldometer.com. From there, worldometer.com, I got this data. You can see So you can see this graph here. So this is all that day-wise collection of data. It's moving towards, it's going towards exponential growth. Okay. So we've collected all this data and put together a table which contains days and number of cases. Okay, there's a, yes, I can see that there's a time delay. Can we have another 20 minutes or so before I explain to you how COVID prediction is done using machine learning? Or if you don't have that, this one, maybe you have other timing or other schedules scheduled to keep up, then definitely you can come back later and see the video. It's okay, no problem. But definitely I have to finish it, right, for the people who are waiting. So thank you for your time so far. If anybody wants to leave, all right. For those who are still hanging around, all right, let's do it. Okay, so what do we have here? We have data, we have date. So we know on 15th Feb it all started, and 15th Feb it was day 1 for India, and the number of cases was 3, right? So on and so forth. On 13th May, on the last I collected this data, we have 88th day, okay, and we have number of cases 78,055. Now all this data can be put into something called linear regression, is what we call, and using that we can predict what is going to happen on 90th day or 120th day. To do that, we are going to build a model. Okay, and what is a model? A model is a mathematical relationship between two axes. In this case, we're going to put days on x-axis and number of cases on y-axis. Okay, with these two in place, we're going to build a relationship between these two and we'll predict. Now you saw the graph of how days and cases, it's starting from 0 moving up till 88. That's what the data we have, and it is moving roughly to 80k. There are points and your data is here. It's moving like this, right? What we do is we try to fit a line. Right? It's a line. This particular line, we are going to try and fit this. We're going to change this shape of it, slope of it, and we're going to ensure that this line ends up looking something like this. So we know the equation of a line is y is equal to mx plus c, right? Equation of a line. This also is the same. This also is the same. Only thing that changes from this line the only thing that has changed from this blue line to this red line that fit the curve is what? M. And of course these also change. the slope and the intercept. X is the same, right? So after doing what we call, there's an algorithm called least square method, gradient descent is also called. So once that happens, we get a line, we get the same straight line but with different m and different c. That new relationship, let's say y is equal to 0.5 into x plus some intercept 22. Now this equation is a new equation, which is this. Okay, now this is your model, right? This is the model. So we're going to build a model which is going to fit our COVID data, and let's explore. So I have built a small equation here. So same data that you saw, I have put it here directly instead of going through importing Excel sheets and making it more complicated. I put it directly here, days and cases. Right? Yes, Mr. Amir, yes, you're right. The real versus and the target value. So we've got days ranging from 1 to 88th day. Now keep in mind that when I say 88th day, the data that was given to me was only the dates. Okay, the dates is very important. 15th Feb, 19th Feb, this is the data I got. Okay, I didn't get this. This was the data I got. But we have to convert it into a scale, because we cannot directly put 13th May here, because the system won't understand. We won't know how to establish a relationship between them. So that's why I have taken it as first day, fourth day, 8th day. This is how we've taken it, and then put them as a list. So we have days, COVID cases, and we scatter the plot. You have right in front of you the plot which is moving up like this, the same curve, right? Then we apply linear regression. It's all terms with time is short here, so I'm going to jump right into the equation itself. The one thing that we need to make sure here is this range is from 1 to 88, but the COVID cases range is from 3 to 78,055. So to plot these numbers on the same plane is hard. So we do something called normalization. Okay, scaling. We scale the data. So after scaling, after using the small scaling function, what was once a range from 1 to 88 is now looking like this. It's all scaled up so that we can evaluate it. So you can see the scale data that you're seeing here. And the place at which your model is building here, it cuts across like this. Okay, I'm going to take this and explain. Go back and I'll put it here. The model has begun like this. Look at the curve, the way it is building. This is where it moves. This is where it has found the perfect model, right? According to linear regression. So we have a model and we have an equation for this. So according to this model, let's find out what the prediction says. Before I say that, before what the prediction says, I'm again confirming to you that my data ends at May 13th, 78,055. We are going to check for 15th, right? And on 15th it is 85,784. Means 13th was 88th day and 15th is 90th day, right? So let's check it for 90th. So once the model was built, we have a model Where's the model? This function. The predict function here is the model. Why is predict function the model? Let's come back. This is a function, that's the model, and it is the model because we took the slope of this and the intercept of it. The new model that is in front of you, the line, the equation, that relationship is having only two unique information in that. That is the slope of this line and the intercept of that line. So we use any function or the c value, the x value, and if we multiply the slope and that value and add the intercept, that's our model. So this small function here is my model. So it means that if I put a new value in here, it has to give me an answer, right? So I put predict 89. Why I put 89? Because until 88 I gave the data to it, right? We have given the data, it has learned. Learning means it has established a natural relationship between that, and then it now gives a value of 44,966. What about 90th day? We already have the data for it. 90th day, 44,648. So according to our model, on the 90th day there should be 45,648. But the reality is, on our day it is 85,784. So there is something wrong. So linearity is not going to solve this problem. Fitting a line across this is not going to solve this problem. So that's why we use something called a polynomial regression. Okay. Again, in polynomial regression, I've done the same thing. I've taken days and COVID cases. But unlike last time, I'm not going to build or ask a linear regression. This somebody asked me, have I used MATLAB for prediction? This is a simple Jupyter notebook on Python. I've used Python and a Jupyter notebook to fit the data and just called a polynomial function and it's fitting it. Okay. So let's look at this. Earlier, when I called a model, I called stats.linregress fit days and COVID cases together. So the function gave me the slope, intercept, R value, P value, and these are our statistical terms which we'll learn later. Yes, you can do it in Google Colab. You just have to put the code in and it is going to stream and serve. Okay, so you got x and y. I've converted that into arrays because my function requires it in arrays, and I've defined a polynomial fit for it. So my polynomial fit gave me this equation now. This is a polynomial equation because the function is not linear. We're using a polynomial regression. Now I've got new model. Earlier our model was very simple. See, our model was here. Where is that? Here. Simple model. Y is equal to slope into x plus intercept. It's not going to work. We need something like this. Y is equal to this new value into x raised to 4 minus some new value into x raised to 3. This is what the model came up with, right? If I do 3 and run it, it comes up with a, if I increase or decrease the degrees that I want, it's going to bring up new models. So let's go and find out what we have as a prediction here. That's it. We have come to the end of it. Let's run all. Hope there is no error. Yeah. Okay. So the polynomial function is fitting. Okay. This now somebody asked me whether this model was predicted by the software. Okay. This model was predicted by the software. Okay. This question needs some clarity. Why should the software predict the model? Look at this. Okay, now I understand why you're saying that. Okay, yes, the model was built by this function. We call for a polyfit of x comma y comma 3, and the functions work. think I need, okay, the functions work. Okay, the functions work is to come up with this equation. Yes, it was done by the software. We cannot hand code it. It has to undergo something called, there are two inner algorithms to do this. There's something called a lease. Agreed, Mr. Sheikh. I got it. Yes. So it was done by, so it's not the software, it is the API that we have used, a small function that is a part of the package. So that small algorithm did it. It's a small algorithm, polyfit algorithm. You can also write once you understand least square method. Okay. So then we do a best fit. It does the best fit as per best fit, yes. So we got this one, and I just went ahead and put that equation in exactly the way it is. And then instead of I can just call it predict also, if you want to call it predict. And then I'm going to change this and put it here, and I'm going to call predict. Okay, I need to run all. All right. Okay, so here you go. Now it's clear. So with polynomial, we're able to achieve 89. Predict on the 89th day, 80,172. What about 90th day? 84,077. What do we have here on 90th day? 85,784. We're still luckily 1,000 cases short. So that's about it. That's the whole idea behind COVID prediction using linear regression and polynomial regression. Okay, Ekta Batra is asking how to decide M and C. Okay, you don't have to decide M and C. That's the whole idea. The lin regress model, the lin regress API algorithm. Okay, this algorithm is going to figure out what is M and C. Now, if you really want to go to the depth of it, how to define M and C? Now, we don't define. First of all, we don't decide. Okay, there is an algorithm which decides it. But how does the algorithm work? I'll tell you. The whole idea is, I told you, right, that if this is a set of points, this is a set of points. You start with a assumption of this line. You start with an assumption saying that, let's say this line is my model. Okay. If you are true, if this is true, then your p-value will be 0. Means p-value, as I saw the p-value. Okay. When you saw the p-value, it is 0 if it is true, but it is false, right? So your p-value here in this case is 1. P is the probability of you being right, probability of you being wrong. Okay, that is what p-value means. So we start with this line and keep on changing the value of m. You don't decide on it, you keep on changing the value of m such that it keeps on changing like this. But you stop, you have to stop at some place, right? You stop when you stop at a certain nice value. You stop when you have most number of points nearest to it. That's the whole gist of it. You keep changing this again and again, move up and down, down and up, and then when to move, how to move, what if you overshoot, The local optimization, the global minimum, the local maximum, all of that, there is a whole branch of study for this. Alright, so this is what the lean regress did. And when I did the poly fit, it did the same, it repeated the same, but in our case it was not a straight line which it was fitting, it was fitting a polynomial curve. So that's the whole idea. Yeah, as Mr. Rishabh Singh is saying, sum of squares of distance of each data point, so the line should be minimum. Of course, in this much there are not too many parameters. So this is a very simple problem. So parameter tuning is going to come into play when you have so many features where will be required to do the tuning. All right, so that brings us to the end of transitioning into data science, the webinar, and the whole idea is, what's your strategy? Okay, the whole idea is what's your strategy, if you have a strategy. But at Analogica, we believe we have a strategy. Okay, so we have our own courses, we have our own workshops, we help you to transition, jump from subject to subject to achieve this quintessential dream or the path to get to this frame, right? So with that in mind, I would like to offer these courses for you guys, and if you guys will enroll in one of our show interest or enroll or inquire in one of our courses, flagship courses called Transition to Data Science. Okay, so we have a course, and the entire course is broken down into modules. So instead of people paying a large sum of money, X amount of money, for the full course, we have broken it down into many modules. So you start with module 1, module 2, module 3, module 4, and module 5. And the module 6th module we have is the major project. Okay, so let's have we'll have a questionnaire, right? We'll have a questionnaire, and I'm going to mail the details of all these modules, and even give you the link on the site, and I'm going to mail the details of how you can take the questionnaire and get your certificate as well. Okay, so I thank you so much for all the patience, observation, and the engagement and the comments. Thanks a lot. Please make sure you subscribe, because we are going to come up with a lot of material, right? We're going to come up with a lot of material, and Mr. Ashraf has been kind enough to remind us again and again to wash hands. Really appreciate it, because it's really the need of the hour. Because before I end, I want to tell you this very important stuff. Okay, a data scientist's insight into what's going to happen, right? See, look at this. Our curve was somewhere over here, and we were at 88 today here, right? In data science, we have something called a normal curve, a Gaussian curve, if you say. This is a curve, this is a PDF. PDF means a probability distribution function. Okay, this is a natural probability distribution. Most of the world's phenomena follow this. All are normal distribution. Yes, the Gaussian distribution. Now where are we here? We are still progressing, we are still increasing. The day we start looking at flattening data at least for 5 or 10 or 12 days, that's when we can know that there is that many days left for it to come down. Our curve looks like it is going to increase. 10 days it increases more, then there is actually a large gap in the final, day on which we are going to be rid of this case. So our problem is to make sure that it doesn't increase. The more it increases here, the scale is roughly about 3 to 4. If you increase the number of days it achieves the flattening, if you increase it by x, the number of days it takes to finally, for us to get rid of it, is 3x. Right? So make sure, because Mr. Ashraf reminded me to wash hands, I wanted to just tell you this fact that yes, you guys need to wash hand and take due diligence in every activity that is out there, and not to panic, but educate others, be wise, and make sure we reduce this and we get this flattening start sooner. I mean, I and you, we are just 50 people, but hope so we'll be out of it soon, and hope you're going to be generating new knowledge. And thanks a lot. Subscribe, like the channel. I'm going to be coming up with great material. We have a lot of other courses, Tableau, cybersecurity, and equally good mentors for all. So all the best, guys. Thank you so much. I'm going to take a permission now. Anything else you guys want to say, you can put it in the group. And if you are not a part of this group, because we have a group going on, if you are not a part of this group, then please let me know and write to us. Simple. It's very simple. Our email ID is very simple. It's just learn@analogica.in. That's it. Okay, learn@analogica.in. So you can always write to us here, because you want to learn with Analogica, isn't it? So write to us here. We're going to give you material and PDFs and stuff for you to choose and get your modular transition from non-IT to data science. Thank you so much. Bye-bye. Yes, sure, you can mail it. Yes. You can mail me at learn@analogica.in. Mr. Rajshekhar, are you in the group? You can add it to the group also. The questions you have, Mr. Rajshekhar, you can put it in the group. If you're not a part of the group, I'm going to send the open invitation link again to all the people, all the emails, so that you become a part of this group, which is moderated and regulated, and it's going to be all about people who want to transition. All the materials that I get, the free stuff, the beautiful videos that other people put when I'm studying it, I'll put it right across in that group. Okay, then you can post a question to me there. Others will also understand, because for me it is very easy to record I just use my pen tablet and put a recording screen on and use my voice and explain the whole thing, and your question can benefit so many other people. So use the group, put the questions there. And I don't know, I'm not claiming I know everything, but I'm only going to claim that I have the enthusiasm and the drive to understand and get to the core of it. I love that. I enjoy it. And I want to just make sure that you also get motivated and charged up. Right? All right. With that, I'm going to end this awesome webinar. I felt good interacting with you guys. The only awesome thing, of course, you have to give me a feedback, but I felt so good talking to you guys with his questions and comedy and humor and everything today. Awesome. Jai Hind, bye-bye. And take care. Be safe.